Hey guys, welcome back to lesson 8.4, where we work on a one sample t-test for hypothesis testing. All right, so here we have a situation where the campus wellness page claims Virginia Tech students average 7 hours of sleep per night, but we doubt in either direction. So we don't think they do. So that means they could get either less or more, but we don't think it's around 7. So we have a sample of 36 students with a sample mean X bar of 6.5 hours and a sample standard deviation of 1.2 hours. So I want to test to see whether 6.5 hours of sleep with a standard deviation of 1.5 hours is statistically significantly different from 7. Now, the formula to, instead of a z-test, we're going to do a t-test with n-1 degrees of freedom, and then here's my formula for finding my test statistic being t. All right, so I have a random sample. Now, the large count condition, as long as my sample size is greater than or equal to 30, which in our case it's 36, the large count condition is met. That is a terrible 36. It's a better 36. Now, if our sample size is less than 30, then we're going to have to graph the data and make sure there's no obvious outliers or skew. Degrees of freedom, n-1. So if our sample size is 36, we would have 35 degrees of freedom. All right, so let's see. The wellness page claims the Virginia Tech students average 7 hours of sleep. So we're going to set up our HOHA, our null and alternate hypotheses. So the claim is that the population of all students averages 7 hours of sleep. And we think that they do not. So we doubt it in either direction, which means our alternate is going to have a not equal sign. Check conditions, yes, random. Large size, large count. N is 36, which is greater than or equal to 30. So the large count condition is met. Our test statistic is T is X bar, which is the sample mean, minus the claim of 7. This is our population mean. Divided by sample standard deviation, 1.2, divided by the square root of the sample size. Square root of 36 is just going to be 6. So 6.5 minus 7. Let's go to, we have 6.5 minus 7 divided by sample standard deviation 1.2 divided by square root of 36, which is 6. So negative 2.5. All right, so negative 2.5 is my t-value. So that's 2.5 standard deviations to the left of the mean, which is quite a bit. So let's find our p-value. Jump the gun a little bit. All right, so negative 2.5 is right here. And since my alternate is 2 ways, I want to shade the area to the left of 2.5 and to the right of 2.5 because it's two-sided. So shade both tails and find it. All right, so I'm going to go to Statlet, t-distribution with 35 degrees of freedom because my sample size was 36. I'm going to plot it. And I want to go outside of a region, so I want to go to the left of negative 2.5. Then I want to go to the right of 2.5. And my area is 0.0173. 0.0173. All right, so my total area, so my p-value is 0.0173. Conclusion. Compare the p-value to 0.05. Since 0.0173 is less than 0.05, my alpha, we reject the null hypothesis. So there is enough evidence. Remember, we reject small p-values. To conclude, there's enough evidence to conclude students do not get 7 hours of sleep. All right. The problem, Bloxburg Transit advertises a mean wait time of 10 minutes. So they advertise a mean wait time of 10 minutes. A student group suspects wait times are longer, so they suspect that the wait times are longer than 10 minutes. All right, and we have a random sample of 40 students with an average of 10.6 minutes and a standard deviation of 2.4 minutes. All right, so my sample size, we'll have a random sample, so check, n is equal to 40, which is greater than or equal to 30, so large count is met. I want to find the test statistic. So my t is my sample 10.6 minus 10 divided by the sample standard deviation 2.4 divided by the square root of 40. So 10.6 minus 10, 2.4 and 40. So I want to set up my So 10.6 minus 10 divided by 2.4 divided by the square root of 40. So I'm at 1.581. So I want to go to Staplet. I want to go to T distribution. I want to... So my sample size was 40, so I'm going to do 39 degrees of freedom. And I want to find the area to the right of 1.5, was it 1.581? 1.581, yes. So the area to the right of that is 0.061, 0.061. So 0.061. So how does that compare to 0.05? Since 0.061 is greater than 0.05, we fail to reject the null hypothesis. If we fail to reject the null, we're going to keep the null. So if we're keeping the null, what does that say about the alternate? There is not, change that n, there's not enough evidence to conclude that bus wait times are longer. All right. So let's look at the beginning of one more example. Macomas trainers claim the mean workout length is 50 minutes. So they claim that the mean workout times are 50 minutes. Regulars suspect it's longer. Regulars suspect the times are longer. A random sample of 25 workouts averages 54 minutes with S is equal to 10. All right, so my sample size is less than 30, but the box plot of the data is roughly symmetric with no outliers. So that's large count condition is met. If we wanted to find the t, that's x bar minus mu over s over square root of n. So 54 minus the 50 divided by 10 divided by the square root of 25. So that's 4 divided by 10 divided by 5 is 2. So we have a t value of 2. Then we would find the area to the right of that. If I want to find the area to the right, let's see. So I have 24 degrees of freedom here, and I want to find the area to the right of 2, 0.0285. So I would have a p-value of 0.0285, which is less than alpha of 5%. So small p-values reject the null hypothesis. If we reject the null, there is enough evidence to conclude that the workout times are longer based on this. That's the gist of this one. All right, so here it walks you through a bunch of steps, but that's essentially what we did. Key terms, one simple t-test is the 6 steps of hypothesis testing, two-sided p-value. If we have to find, if the alternate hypothesis is not equal to, and we have to find the area to the on either end, and we have n-1 degrees of freedom. So that summarizes it. It's looks at the gap between x bar and the claimed mean. 6 steps are what we're working on. Sleep claim was rejected because of the small p-value, but the bus claim we failed to reject because of the big p-value. The bar does not move enough after the evidence is in. More power might settle it. And that is lesson 8.4.